Assalamualaikum warahmatullahi wabarakatuh. Here is another example related to the implementation of test of homogeneity. So what we have here is two drugs that were administered to two groups of randomly assigned patients to cure the same disease. So here we can see that this is more than one population, and we have two drugs administered to these populations. One group of 60 patients and another group of 40 patients were selected. The following table gives information about the number of patients who were cured and not cured by each of the two drugs. Test at 1% significance level whether or not the two drugs are similar in curing and not curing the patients. So that's where we can have our starting point, which is to write down the null hypothesis and the alternative hypothesis. So notice here that there is this word are similar in curing and not curing. So this represents the null hypothesis. Right, so the null hypothesis is drug 1 and drug 2 are similar in curing and not curing the patients. As an alternative, we can just write down a statement that is contradictory to the null hypothesis, which is drug 1 and drug 2 are different or not similar in curing and not curing the patients. That is step 1. Now for step 2, step 1. Now in the second step, what we need to do is we need to obtain the value of test statistic, which is given by this formula. And of course, E on the other hand can be obtained if you consider the total of the row times with the total of the column over the grand total. Okay, so we need to find what are the expected values for each different cells given here. Right now, this is the total. This is also a total. Right, now 44 plus 18, this is going to be 62. 16 plus 22, this is 38. And of course, if you add up this total of the columns, the answer is going to be equal to 100. Now for the row, this one here, if you add up, it's going to be 60. And if you add up this, it's going to be equal to 40. If you add up these two together, it will result in a grand total of 100. Now, in order to find what's the expected value, for this cell here, we need to have 60 times 62 over 100. And now what you have here is going to be 37.2. For this cell here, it's going to be 40 times 62 over 100. So it is 24.8. On this cell, it's going to be 60 times 38 over 100. It's going to be 22.8. And lastly, you have 40 times 38 over 100. That is 15.2. So we're going to use these values and apply straight into the formula here. What we have is 44 minus 37.2 squared it over 37.2 plus perhaps this one, which is 18 minus 24.8 squared it over 24.8. Continue doing the same way until the last cell. For example, this could be the last cell, so that is 22 minus 15.2, you square it over 15.2. and the result that you get is 8.178. So you will get 8.178. Now on the third step, we need to find the critical value. So we are using the traditional approach. We want to find what's the critical value. Now the degrees of freedom is R minus 1 times C minus 1. R here is the number of rows. So we have 2 rows, which is 2 minus 1. And we have C. C here is the number of columns. We have 2 columns, which is also 2 minus 1 then. And degrees of freedom is equal to 1. We know that the shape of the chi-square distribution when degrees of freedom is 1 is going to look like this, more or less. And we need to sketch the critical region. So the critical region is going to be on the right tail of the distribution. The area is going to be 1%. So this is 0.01. Our job is to find the critical value, which is the value on the horizontal axis here, such that the probability of getting this value and bigger, which corresponds to the right direction, the probability of getting this value and bigger is going to be equal to 0.01. Now what you can do is you can refer to the chi-square distribution table, degrees of freedom 1, area is 0.01. You will see that the critical value will be the critical value here will be equal to 6.635. Therefore critical value is 6.635, and the position of 6.635 is at this point here on the horizontal axis. So this is the position, 6.635. Now if you want to decide whether the null hypothesis can be rejected or not, step 4 is to make a decision. You need to compare this value with the critical value. You can see that 8.178 is going to be somewhere here. You can imagine that falls into the critical region. It's going to be on this side because this value here is greater than 6.635. Yeah, so we can say that the test statistic 8.178 falls into the critical region. Therefore H null is rejected. H null is rejected. Now step 5 is to come up with a conclusion. So step 5, we're going to come up with a conclusion, which is enough evidence. There is enough evidence to say that drug 1 and drug 2 are different in curing and not curing the patients. So enough evidence, I'm just going to not write this part because I really don't have much space, but what we can write down is just as simple as this, which is there is enough evidence to say that drug 1 and drug 2 here are different in curing and not curing the patients. Alright, if let's say you want to solve this example using the p-value approach, you will have the same procedure for the step 1 and step 2. Okay, so step 1, same idea. Step 2 is also the same idea, which is when you see that the test statistic here is 8.178. Now on the third step is to find the p-value. So basically, this is the chi-square distribution curve, and you need to know the point of 8.178 you could say that this is the point 8.178, and you want to find what's the area on this side. Okay, so what's the area? So degrees of freedom here is equal to 1. We know that degrees of freedom is equal to 1. The test statistic is 8.178. Then you can refer to the chi-square distribution table. Degrees of freedom 1, so we're going to refer to this part. Degrees of freedom 1. And you can see that throughout these values here, the values here are increasing, and the value of 8.178, if I may write it down, it will be somewhere here outside of the table. It's not even inside the table, so 8.178 is going to be somewhere here. Now at this point, we know that for value 7.879, basically what it means is for value 7.879, the area is very small already, which is 0.005. So therefore, if you're talking about this point, which is 8.178, 8.178 could be somewhere here, 8.178. Therefore, the area from this point to the right here is going to be even smaller than 0.005. So we are going to use that as a basis of our answer. Now we will say that, we will say that the area here for 8.178 is going to be less than, so area here is going to be less than 0.005. Now since this is a one-sided test, since this is a one-sided test, therefore the p-value here is also going to be the same value as given here. So therefore p-value is also less than 0.005. Yeah. Now on the fourth step is you're going to compare p-value with the significance level. So here is p-value and here is the significance level. And what's the value of this? The value of this is less than 0.005. What's the value for significance level? Significance level is 0.01. Now clearly you can see that this value is less than this value, yeah, so we can say that p-value is less than the significance level, therefore H null will be rejected. So based on this, you will decide to reject H null. Now the last step, which is the conclusion, will be the same as what you have seen in the previous slide. So this will be similar to what you have seen in the previous slide, which is there is enough evidence to say that drug 1 and drug 2 are different in curing and not curing the patients. Alright, I think that's all for now. Thank you very much for watching.